first announced it was 2%. By the way, is this fixed? You want to change it? How about that one? You guys good? Good? 不要再换了吗？都不要再换了，不要换了。好。So I'm gonna go ahead now. So he won't fail the class. He won't fail. Okay. He won't. So will you fail this class? The answer is no. All right. Thanks for changing. Whoever changed it, then thanks for changing the answer. Right. Great. So the answer is no. Okay. He will not fail this class. All right. So for those that answer yes, I strongly recommend future-wise also spend some time with computer math. But okay, let's get back to this. Yeah, I mean, right, the poll is done now. There's no further change. There's no point of changing this. This is not accounting. This is more accounting or finance.
你那个算出来那个-2，它是看那个常态分布的做决定嘛。-2就是它那个 z 算出来就是-2。
我们没有用什么是-2，
就是40去减它64，然后去除以它的标准差是10，就是-2，然后去看它的常态分布对应到是2点多。
对。然后我们就没有用到什么 z 啊，-2
z 不是 z 的算法不是那个40分，因为要考40分嘛，啊减掉60分。
哦，我这没有给你提到，就是只有标准差。
对啊，就是要算 z。
两个就是这样。哦，等一下，我这边要讲就是，so let's how help you answer your question? By the way, did you answer yes or no? Yes or no? No, you won't fail, right? Yeah, yeah, you can look at the z, right? So the easiest， 不要动了，我觉得你好像弄得蛮复杂的，就是然后这So the class is average is 60, right? So if you look at the distribution, the 60 is in the middle, right? Okay, and standard deviation is 10. So the first standard deviation, right, over here, and move on second standard deviation, right? So second deviation meaning that you deduct 20, right? So it's then over here, but the second deviation is 40, right? 40. Okay, you still guys agree? So on the 40 standard deviation, the score right now is 40, and meaning that over here the cumulative percentage is 2.3. And I say that I will fail 2%, meaning that it's below this 2.3, all fail, right? But you have 40, so you have 2.3, so you will pass. Okay? Clear? I feel good that this is done. So I think the reason why I'm showing this is to kind of state that this is assuming the class has a normal distribution, right? Right? But normally in a lifetime scenario, you won't have a normal distribution. You probably have binomial, meaning that you will have something like this. Or maybe you have a skew, negative skew or positive skew. Something like either stuff. But this is assuming you have a normal distribution, okay? So a few things to think about. These are the questions I think I won't talk more in this class, but I think it's important for you to bring back to your research or at home to think about it. So we are assuming your data are normal distribution. So this is hold true for any of the research. A lot of people think it's normal distribution. That's not true. Second is, what does small standard deviation mean? 它有一个很大的问题，代表的含义是什么？相信大家都应该知道我们不来讲。So other than average and standard deviation, to express our data, I think this is very sad today. Most of engineering doesn't take statistic classes, but you do have to realize that there is more than standard deviation and average. Okay? So I want to give you a great example. Yeah, so the great example is data. So A, B, this is 100 MPa, and the standard is 5. And this is 105 MPa, and the standard deviation is 4. And 4.8. So this, by the way, this is actually a true number. 4.8. Last year I was sitting in a master defense 一个硕士的那个硕士大便 and they do a 4.8. He reports to one number. This is the average number. So this is the AVG. Yeah, average 100. So there's two specimens he made. So this is 10 specimen, 100 PA, and another different process weight 105 and 4. So at the conclusion, he announced that this is better because this has 105 MPa, right? 105 MPa, and the standard deviation is 4. Right? Yeah, yeah. So it's very tight. It's a very tight range. Right? It's a very tight standard deviation. If it's smaller, it means tight. All the specimens they are roughly in this 105 range. While at 100 MPa, the standard deviation is a lot broader, wider. So his conclusion for his thesis and his paper announced that miraculously, B process parameters is significantly better than A. Is that true? Now, for those of you that hasn't taken statistics, I'm afraid to say that this is not true at all. Because if you do a two-sample t-test on your specimen, and this is very popular, what it does is that it helps you determine if two population needs are equal, and this is well already done in industry as well. These two numbers that I have just stated, there's no such difference whatsoever. Okay? They are practically the same. Okay? So this process problem, this is really no much differences. Okay? Do not be deceived stating that 105 is higher and the standard is narrow, this is wider, but from a bigger bird's eye view of looking statistically, chances, they are the same. There's no differences. Alright? So two sample t-tests actually help you do this. So I just want to give you perhaps some, some idea, maybe some give you some, research of doing is that if you, again, plot average and standard deviation on your research, is that really all you can do for your research? Perhaps you can think a little bit more deeper, right? So this is an idea, right? So I told that graduate student that, are you sure? If you're sure, you're confident, please go ahead. If not, think more, okay? So another thing is I know it's also compare difference between more than two groups. So ANOVA is also being done. I don't expect you to do that in the research, but in my research group, I do expect my students to be well familiar with ANOVA. Again, I'm just sick of looking at standard deviation average because, again, you can do more than this, right? Right? So let's continue. So impact of defects on determined strengths, statistics scatter for defect size, statistics scatter for fracture data. Right? So you can't just give a failure. It doesn't make sense. You need to give the failure probability instead. So this is what the statistic give you is a probability, right? They give you chance, right? Rather than give you again average and standard deviation. Probability is better for recognizing all the data and how does it show you. Okay, strength as probability. So how do we do that? So assume defect are distributed within a component, crack propagation from one component cause failure. Right? So for example, if P stands for probability, chance, right? F means failure, right? So for example, if you are at 2 MPa, and that chance is 30%, you can say 0.3. Alright, simple as that. So it's like a probability that a component will fail when a stress or strict stress is applied. So you can write distribution of failed stresses. So you can write that equation, y law statistic, that's the stress within your input, 1 minus exponential minus sigma divided by sigma naught m. Okay? So a few things to recognize is m over here stand for y law modulus. And sigma naught is 50 for Alright, so if you still copy, that's fine. I can post that this a little bit later. So I'm going to continue to move on. Okay. So he's normally what you see on that web statistic response, the distribution or field stress. So likely wise, when you do statistics, you will have plenty of specimens when you do a test. Right? It's not going to be 2 or 3. It's probably going to be 15, 20 specimens. Okay. So what you do is, for example, you have 20 specimens. You do 4-point ranking failure. You plot these numbers out, right? You plot, and then the failure probabilities. And you plot it out. So again, how do you do a failure probability? I'll explain a little later, but this is how normally you plug in your number like that. And as I stated, is the whiteboard boundaries, right? And sigma naught here is the characteristic strength, or what we so-called the fitting parameter. Okay, so over here we have two numbers. M equals 10, 300 MPa, and M equals 10, 600 MPa. So what does that refer to? Should we write that? What does that refer to? So, yeah. Okay, so what this means is that the critical strain, this one, okay, so we have these two. So number one, M equals to 10 when equals to 300 MPa is the red one. The blue M equals to 10 extra 600 MPa is this one. Okay, so the modulus, what does it mean? You can again think about that as a standard deviation, right? If this number is larger, meaning that the data is more wanting. So if this number is larger, meaning that the data is less scattered. If the number n equals to n is smaller, meaning that the data are more scattered. Okay? So regardless, these two are the same, right? So the curve over here is the same. Okay? The curve is constant gap. Now, sigma naught is 300 to 600. Where do you see that from this over here? It's in the middle. So scatter amount is the same. Okay, because n equals to 10. Does that make sense? Does that make sense? 有懂吗？哦，有没有懂 ？Okay. Now let's continue moving forward. So what happens if n equals to 10, n equals to 5, and then these are the same, 388. So we can pass on 388 is with the median value. So if it's 388, it's likely not going to change. So this is the 388. Right? So when you guys say higher n means narrow range of failure stress. So higher n means narrow stress. So you have 1 and 2. So for the blue line here, do you think it's 1 or 2? Is it data 1 or data 2? This is blue line. This is blue line. 2. Everybody agree? Is it 2? 2. Maybe 2. Okay, yeah. So that's 2. So this one is 2, and this one is 1. Okay. So again, what the n shows you is that if the n, the Bible offers, if that number you see is higher, meaning that it's less scattered. 代表它的你今天所得到的这些 specimens， 它们非常集中。如果你今天得到 n 的值它越低的话，代表说它的值分散的开来。OK， 就是一个标准差平均的概念。OK 吗？好，我们继续往前。So how do we find n and sigma not? How do we find how do we find that number using this equation? So there's a few math we have to do before we get that. So let's play around with that. So let's move the 1, 2 on the left hand side. Let's make sure. So I'm just moving these constant numbers from left to right and right to left. And you'll see why I'm doing that a little bit. Right, so please go ahead and copy this down. So the concept of doing this is to just move each of these terminology around simply so that we can show y equals to mx plus b. So the importance of doing this is that later, when why mean that this chunk of stuff, right? And n and x plus b, all these numbers, we can then draw points on the graph to determine the lines. So I'll explain that a little bit more later on my next slide. So now we know that n over here is the modulus, right? The x over here is length, L stress, right? Minus n, L, and then the sigma naught. So this entire thing is the V, right? And then mx modulus and stuff, right? So I think it's interesting to see that if we say that x equals to 0, this we knock out, and then we know y equals to b. So it's these kind of relationships we can later determine the n and the 50 parameters, sigma naught. Okay? All right. Do everyone have this practice sheet? Make sure you don't have one. You don't have this one. Okay, good. We're gonna do this practice. All right, I'm gonna take if you're still copying this down, please take a photo and we can move on. Try to finish this. Okay, that's all. I'm gonna go back to all here. So a few things is the effect of component development here. So supposedly, you have two specimens, E1 and E2, right? So if you connect it together, that's the entire specimen B. But if we chop it in half, we have E1 and E2. Okay? Now let's do a quick statistic. If it failed, if it's good, meaning positive. If it's negative, meaning that it fails. Couple Y. Okay? So sometimes you have a specimen. I want to know like the chance. So you either have plus plus, minus minus, like that, or you have plus minus plus minus. So bear with me. What does that mean? Is that today you have these two specimens connected together, meaning that if it's 2 plus, it's 10 plus, right? The specimen doesn't fail. Okay? Now, if you have one side that's negative, right, meaning that it doesn't matter, the entire specimen fails, right? Same as minus and plus, meaning that it fails, all right? And if two sides fail, it still fails, right? Does that make sense? So, interesting enough is if we just look at E1, right? What's the field probability of E1? It's 50%. Okay, because it's 50%, right? It's sitting here around 50%. Now, if we look at E2, that's also 50%, right? But things get complicated if you have a total, right? Meaning that you combine these two. What's the field percentage? That's 75%. 它是70%的对，所以做所有的陶瓷材料都有所谓的放大效应。Okay, so those are these limit. You always have somebody magnify for these kind of stuff happening, right? So the effect. So we also need to consider the effect of value on stresses, right? So that equation that I just kind of wrote, PEF. I'm just going to rewrite that equation. V means the value minus the exponential. Is minus V, V naught. So the only thing I just added in this equation right now is this part. It's this over here, this terminology. And what this means is that the V over here stands for the component. And this is the reference value. Okay? 所以看你要总是有个相对值嘛。So there's always some reference you need to consider. So for example, this is the printed specimen and this is the real component, right? So this one is larger than this one, right? So what you do is that this is the component, this is at the numerator, and this is at the denominator. 会分部分，它的体积是这样子。 OK 吗？我们今天不会探讨这个，但是我是让你知道。So statistic approach to failure is PF again is the value minus 1 minus exponential minus sigma sigma r. Alright. Okay, so this is a minus outside. Okay, so this is a minus. Okay, don't forget. Alright, and it's very clear. Alright, so I don't want to continue any time further. Let's move on. So how do you in real time, how do you use the whiteboard statistic test? We're going to practice right now. So first, you conduct many experiments. How many experiments so that whiteboard statistic functions at least minimum 15? How many data did I give you in this test? 12, right? So this is not legit. If you do an experiment, you need to have minimum 15 so that your whiteboard statistic can be valid. Okay, that's the minimum number. So 12. Now here you come. So you need a large N. So large N means that large samples. So example data I gave you this over here. What right now you're supposed to do is step 2 is list or fill the stress from minimum to maximum. So example, I give you the first two numbers, the lowest 234 to 57.4, and then please do your homework right now. Do your work, not homework. Do your work right now and start labeling from the smallest to the maximum. You do that right now. So find from the smallest to the biggest. 从最低到最大。Alright, so I already gave you the first two numbers, 234, 257.4. Listed the minimum number to all the way to the maximum. Please do that right now. So 你知道做什么吗？这给你12组数字哦，就给你2组了嘛，那你就从最低爬到最高，所以在 minimum 到 maximum 这一栏位把它填下去。所以第一个是要填2、3、4嘛，第二个填2、5、7、点10，然后第三个要填下一个是哪个？把它填出去，把它找一下，可以吗？可不可以？算一下吧，你有看吗？你排出来了吗？啊？填完了，搞定了，好，很好。今天看那个，你今天有空可以那个吗？还是明天给我看？你说我也可以，排在一起哦。然后7点来。哦，是哦。哦，你说在骑车我来，对。就回家休息就好，明天不是不知道。看起来。
哦，因为我们因为 meeting 完了，我们要去学那个小孩子。花了时间。
好，不然你回来就给我看，可以吗？你再直接扣啊，我们因为那个门还关着。 much还有那个什么专题那个好玩的东西。Okay, so I think, is everybody done? I think it's fairly easy. If you're not finished, you can take this back home. So what's the next step? So step 3 is find the cumulative of the probability of the failure. Right? So how do we do that? So this is it. Excuse me. This is the equation. Pn equals to I minus 0.5 divided by n. So n is paid for how many specimens you have. So supposedly if you have 12 specimens, right? Your denominator is 12, right? And I mean that the first specimen, or the first minimum failure, we put 1. So 1 minus 0.5 divided by 12 is 0.042. That's the probability. The second one here is the same as 2 minus 0.5 divided by how many specimens? 12, right? And it's 0.125. Third number is equal to 3 minus 0.5 divided by 12, and calculate that. 4 and 5, 6, 7, 8, 9, 10, 11, 12, same on over here on the I. N is always constant, it's 12, because you have 12 specimens. Okay, so if you can do that right now, is go ahead, I already gave you these two, and you can do the same, you just check if that makes sense. Okay, so 0.042 is 1 minus 0.5 divided by 12， 1减0.5除以12。那这个是2减0.5除以12，那下面就是3减0.5除以12，4减0.5除以12，一样子。然后就把这12个，Please go ahead and then do the calculation from 1 to 12 and go ahead and put the probability down. Can you do that? So if you don't have a calculator, it's fine if you want to go ahead and then look from your college if you have a calculator and then just copy the number down. This is just an overall practice for you. Alright, so that's the equation. 1 minus 0.5 divided by n. By the way, is that person from next class speaking into each other? The sound here. No. Is it Indonesia? No. It's very annoying. I'm having class and I'm hearing people. Terrible facility over here, by the way. Alright, so I'm gonna continue moving forward. So if you do everything correctly, what you see right now is over here down below, you have a empty thing over here, and on the y-axis is the PF. So, and on the axis is the failure stress. So this is the answer. So for first, the minimum, if it's 274, right? Go ahead and find 234, that's over here, and then what's the probability? It's 0.042, right? Put a dot over here, and then continue. So these dots over here are all the 17 numbers you're supposed to get, right? So let me go ahead and do this again. 就是你现在有12组嘛，那这个栏位就是从一个 maximum， 就是你刚才排序的，从低到高。accumulative 的话，就是从0.042、0.12嘛。那这下面这个表格就让你可以去把你的 failure stress， 就是你刚才从最低到最高把它排出来。那怎么排出来？就是看你的 y 是那个几率嘛，从最低排到最高。那如果你有排对的话，你就会形成一个这样的格。So if you calculate everything correctly and done everything correctly, you're supposed to map each of these 12 data points onto this schematic here, from the lowest point of the probability to the highest probability. Okay? So please also do that.价格4.20，对，哦，不用很精准了。I don't have to be precise. You have to be done. Okay, good. Yeah, this is roughly okay. So here's the thing is that if you look at this graph, I go ahead and draw 50%. 50% you go and draw is about 280, right? So without doing any calculation right now, I can take the characteristic stress or the strength or the fitting around the sigma naught. This graph. So in whiteboard, there's two important parameters. Again, we need to remember one is the n, the whiteboard modulus. The second is the characteristic strength, fitting parameter, right? So looking at this, the 50% is about 280. So I can guess this is roughly about 280 MPa. Okay, without any calculation. All right. So let's continue. So find n. So now we need to find the n and then the sigma. So this over here, you already have all the numbers for mixed and maximum and the cumulative. So if today, because right now you guys don't have a computer, right? So if you have a computer, of course you have Excel, you can do Excel. And what does the Excel do is that you need to plot something using the Excel. So remember, this is the equation that we already derived from the y-force statistic. And so this equation shows that this over here is the y value, all right? And this is the slope, right? And this is the x. And this over here is the intercept, right? 就截取，所以 y 等于 mx 加 b 就 b 是截取嘛，这个就数学基本国中数学，你们应该都知道。So with those 12 numbers using Excel, we're able to plot the y graph because the PF we already know, right? So we can go and calculate this and plot it x and y, and we also know this with this, right? And then using the linear fit function in Excel, we're able to plot this line straightforward, right? So with this line, what does this line actually do? We then know the slope. If we know the slope, we know the m. If we know the m, that's the y modulus, right? Now, the Excel gives you the perfect fit, right? 就是那个最佳的 fit 的那个东西。那如果你不知道的话 we can do a quick math, right? So if we do this is delta y, this is delta x, right? You can say that this is about 1.39 and minus 2.58, right? And this is 5.5, 5.7. I'm just giving you a rough number right now, so if you do y divided by dx, 1.39 minus 2.58 divided by 5.75 minus 5.5, you get n equals to 14.18. This is through just math calculation. If I just arbitrarily draw lines and calculate the slope, right? But if you use Excel, and then it gives you a linear fit， 就是那个线画那个线的话，它会直接给你 y 等于 x 加 b 的那个规律，然后一个 slope 的话，它 m 也是到在这个值，所以这时候已经知道了 y modulus m 就是14.48。So now you already know the y modulus is 14, right? So to give you an idea, normally if m is higher than 10, it's less, meaning that this data is less scattered. Anything that's below 10, meaning that it's very huge scatter. 10是可以看到的，这10基本上有个指标，就超过10基本上代表说你的这些数字它是很 concentrated， 这个值要把它记得 ，OK？ 我跟你讲，这样说并不是正确，但是通常是一个指标，可以看 ，OK 吗 ？So let's continue on. So this is the same data that you plotted on your sheet, and this is the answer. Then I'll go ahead and draw it as well. So over here is y again, we minus mx plus b. So now we already know 2.58. What I'm just doing is I'm plugging in the number 14.18. 只是你一般is the modulus, right? Times 5.5 plus b. So minus 2.58 and 5.5. Where is this number coming from? This is just the number from over here. I arbitrarily grab. 这数字是怎么出现？是我随便抓了一个数字。OK， 从这个线随便抓一个数字，然后把它带进去，然后我算出来 b 等于负的80.57。OK， so b, if you know b, it's not easy. And that's right. And if you move sigma naught, e is b divided by n, and sigma naught now we know is 293 MPa. All right, we'll just calculate that. And n you already know is 14. Okay? So using Excel, if you just use the linear fit, your sigma naught is like 294 MPa and n is 13.1. Anyway, it's roughly along that block number over there. So just use Excel, that linear function fit, you get this number. Alright, but if you use any calculation, that's this number over here. So we use the same right? In calculation. In calculation. Alright? Is that clear? Any questions so far? Alright, so summary right modulus, this is the equation. So PF is about political failure. PF 0.05 means average strength of 50% failure. Sigma F means strength of failure. Sigma naught is a scaling from, or also known as characteristic strength. Alright? 是 narrow distribution。高的 x 代表你的 data 量它分散的越少。OK 吗 ？Alright, this is the deviation. Alright, so n is the white largest, large white is desirable. So large white large is desirable, less variability data. Rank sample in auto failure is determined PF by this failure and n is the polynomial template. Okay? Any questions so far? Is that clear? 今天主要是要跟你讲 white ball statistic 的整个过程流程。Any questions so far? No? Alright, so if not, I will see you next week, and next week we will have an invited guest to talk about simulation using Vortex 3D. Alright? So if you don't have any questions, let's call it a day for today, and then hopefully see you next week. Alright? Okay.